Sometimes you need to 3D print a part that is kind of hard to figure out how to orient for supports. This particular piece, for instance, it's kind of tricky to figure out how to lay this out if you print it as one part. If you split it into two, well, then it's a lot easier. But putting it together, if you don't have any special features, can be somewhat tricky. Here, I'll show you how to do this using splined discs of various sorts. The basic version of this consists of a splined disc and corresponding slots cut into your parts. You assemble it by putting glue into the hole on one part, inserting the splined disc, and then gluing the splined disc and the other face of the part, and assembling. In this version, the splined disc is not a very tight fit, but in yours, you should make it a tight fit. This is just for demonstration purposes. You can see that it wiggles just a little bit. In an actual part, you want the fit to be tight enough that you have to actually press hard to get the splined disc into the part. When your parts have to be assembled with a specific orientation, so that different rotations aren't acceptable and there's only one rotation that actually is correct, you can use a splined disc with rotational asymmetry. So this splined disc will fit into here in this orientation, but if you try to rotate it, it simply won't fit because this gap is trying to fit in place of that notch. If I used this spline disc, which has no asymmetries, well, it can go in this way, sure, but it can also rotate like that. Now for the spline disc, well, that's not all that problematic, but because the spline disc has no asymmetries, this piece can fit together with this just fine, and it doesn't matter what angle it's at. Using a rotationally asymmetric splined disc prevents that. There's only one angle that this splined disc will permit this to join up. If you try to put it together this way, you can see it almost fits. But the fact that there's no gap there means that these notches can't be pushed in. It has to be rotated this way, and then it can go together. The splined disc does not have to be a separate part like in these two. You can integrate it directly into one of your parts. Here it's the base. Ideally, the splined disc should fit into the slot fairly snugly. These two require a significant amount of pressure to be pushed together. That's good because it means you don't need to use glue in order to hold them together. You can, of course, use glue, but it shouldn't be necessary. Here it is fully pressed in, and I will try to show you how difficult it is to get it out, even though there's no glue. That took a bit of effort. That's pretty good for no glue. If you did glue this, the bottom is a little bit rough here, you can see, because this was printed like this, and so all of that was bridging. So you might need to use like a bunch of extra glue to actually attach these. But the fit is so tight that you really don't need glue. It's a little bit of a pain in the ass to put together that way. You have to press it against like the edge of a table or something to push those splines all the way down. But once you do that, well, then it's like pretty solid.